Okay, so last lesson, guys, we were doing the imperial system, right? And we were going between, let's say, like feet and miles. Or we would do, what else were we doing there? We would do ounces to, what do ounces go up into? Ounces to, ounces to pounds. All right, so now what we're doing is we're going to be switching back and forth between the two of them. So we might be given something in metric, and we have to convert it to imperial, or we're given something in imperial and we have to switch it to metric, right? We have to be able to go back and forth because we live in Canada and things are measured in imperial and in metric, right? Okay, so here's some examples. So we've got like imperial. 1 UK gallon would be the same as 4.546 liters, and just notice that we get a bunch of equalities here. So like one thing is equal to another. Okay, for the most part, we're just going to use these to do the same thing we did last time. Do you remember how we like put something over something, we canceled the units and came up with a new unit? The good news is it's going to be pretty much like last lesson. Okay, as long as you've got the actual conversion factor, then we're going to be good to go. So I'm just going to kind of refer to some of these so while we're doing these questions. So this one says convert 20 kilometers to miles. All right, so can you guys write this down with me, because you guys will have questions like this, right? So we are going to go 20 kilometers, and we want to change it into miles. Okay, so what we're going to do, see if you guys remember this, we multiply this by some factor, right? Something over something. Now, am I going to put kilometers in the top or in the bottom? Bottom, right? Because I want to cancel it, right? That's the whole goal here. I want to cancel kilometers with kilometers, and then miles in the top. Now all that's left, I just got to like look on my chart and figure out how many miles are in a kilometer, or kilometers in a mile. It doesn't actually matter which one we do there. So where'd you find that? So length, we've got imperial, so we got mile and kilometers there, right? Notice that on this side, we've got 1 kilometer is equal to 0.621 miles. It doesn't actually matter which one we do. And you know what? For the sake of this, I'm going to do both. So I'll show you both ways. So this first one says 1 mile is the same as 1.609 kilometers. Okay, so 1 mile is the same as 1.609 kilometers. All right, so this is looking good because our kilometers cancel, right? That was the whole goal there. And the only unit I have left is miles. Now, if the number is in the bottom, what are we going to do? We're going to multiply or we're going to divide? We're going to divide, right? If it's in the bottom, then we're just going to go 20 divided by 1.609. So get out my calculator. 20 divided by 1.609 is 12.43 miles. Okay, and I want to show you why it wouldn't have mattered too. So let's do it one more time, but I want to show you with the other conversion factors. So if we would have started out with 20 kilometers and we multiplied by, so make our brackets, and then we're going to put kilometers in the bottom, and we're going to put miles in the top. Okay, let's use the other one. So you could also say in 1 kilometer there is 0.621 miles, so not a full mile, right? Which makes sense. There's like miles are bigger. So we could write it that way too. I could say, okay, in 1 kilometer there is 0.621 miles. So again, kilometers would cancel, so we're good to go there. But now it's up in the top, right? So are we going to multiply or are we going to divide? Multiply, right? When it's up in the top, we're just going to multiply across. So 20 times 0.6 to 1, I get 12.42 miles. So those should have been the same number, realistically, right? The reason that they weren't was just the way that these numbers were rounded, right? But that's pretty close, right? 12.43, 12.42. Those are pretty much the same number, right? So just know that we could have done it either way, right? So grab either one of those conversion factors. All that'll change is whether or not you put the number at the top or whether or not you put the number in the bottom. All right, next one. Convert 27 inches to centimeters. So I'll start you guys off. We're going to say 27 inches. You're going to multiply it by something. So make your brackets. And then I'm going to let you guys try. So let's do this one. So am I going to put inches in the top or in the bottom? Bottom, right? Because we're going to cancel inches. And I'm going to put centimeters. So cm in the top. And now I just got to find the conversion for that. So how many inches are in a centimeter? Or centimeters in an inch, it doesn't matter. So I'll do inches in the centimeter. Oh, so 1 inch is 2.54 centimeters. Okay. So 1 inch is 2.54 centimeters. Did anybody else use the other one? Did anyone else use 1 centimeter is 0.394 inches? Okay, you could have done that too. Okay, but I'm doing this one. All right, so they cancel, right? Inches cancel with inches. We're going to be left with units of centimeters, so we're in good shape. And then whatever that is, anyone know that one yet? 63.18. Bird. Yep. And then you might see that maybe the answer is 63.2, right? Just rounding the 8 up to a 2. Or even in this case, you could just say that that was 63 centimeters. All right, let's do it again. We're going to do lots. Convert 10 meters to yards. 10 meters. All right, we had a little typo. Should have been 68.58. So then 68.6. Yeah, we'll keep it like that. Good enough. It never asked for a certain amount of decimals there, so I'm gonna do this one too. So I chose this one. That 1 meter was the same thing as 1.094 yards. Anybody else do the other one? You guys chose this one too?
It says 1.093.
Would you stop correcting me?
That's right.
No, I'm just kidding. That's right, yeah. Okay, good. 1.093 yards. Okay, so then good. Oh, is it 3.6? What did I get?
I did it the other way.
1. Oh, oh, you know what? You're looking on your formula sheet, and I was looking on this one. So sometimes that'll happen. The numbers that we got will be rounded to different decimals. So yours is actually just more accurate. Okay. Right? So I'll stick with mine, the 0.94, but you just know that your answer would have been a little more accurate than my number.
He has too much pride to change his answer.
Yeah. Okay. So then all we're going to do is multiply, right? 10 times that would be 10.94. And yards. So sometimes yards is written as YD or sometimes it's written as YDS. So. And then again, maybe 10.9 would be good. All right. Are you guys good on that? Do this one. So I'll skip through this one just because we've done a bunch like that. So let's go. Molly needs 15 grams of sugar for a cookie recipe. All of her measuring devices are in ounces. How many ounces of sugar does Molly need? Right? So this is a common problem, right? That where maybe a recipe calls for a certain amount of like grams or something, but all you have is like a measuring cup that measures in ounces. So how do we do that conversion? What if you didn't have Google?
Use Siri.
What if you didn't have Siri?
Use
Yeah. Alexa doesn't know. Right. That's right. Okay, so we're going to do the same thing. Let's write down 15 grams.
Yes.
And then we are going to figure out how many, well here, we'll put our brackets down. Is grams going to go on the bottom or the top? Bottom. And ounces, so OZ on the top. How many ounces in a gram? So I'll look over to the mass one. So 1 ounce is the same as 28.35 grams. And it was 28.530, but I don't need to write the 0, do I? Okay, so good. Grams are going to cancel with grams. So we know we're just going to end up with ounces. Am I going to multiply by that number, or am I going to divide by that number?
Doesn't really matter.
It does. It will matter. So we're going to go 15. And another way of asking it, is it in the bottom or is it in the top? You'd divide it because it's in the bottom, right? Yeah? Do you kind of see, like, if the number is in the bottom of the fraction there, then multiplying by 1 over 28.53 is the same thing as just dividing by 28.53. Okay, so whatever that is. So 15 divided by 28.53. So we end up with 0.53 ounces. So if you were really measuring this thing out, right, and you had like things that measured ounces, you'd want half an ounce, right? 0.5 would be about a half. So I'd want half of an ounce. So you'd fill that thing probably halfway up. Okay. All right, Molly needs 15 grams of sugar for recipe. Oliver measuring, oh, whoop. Ignore 6.
Ignore 7.
Oh, geez. What happened there? All right, so on to 8. I have no idea what happened. All right, the Townahai River covers an area of 14.27 kilometers squared. To the nearest tenth, how many square miles does the town cover? All right, so this one's going to be a little bit tougher because we're dealing with area now, right? So kilometers squared, right? So we can do something similar though. If we look back up, convert square kilometers, right? That's like the area of the field or whatever, to square miles. Well, okay, so 1 square mile is the same thing as 2.59 square kilometers. So 2.59. I'm gonna write that down. 2.59, so we don't forget. All right, so we're gonna write down 14.27 kilometers squared. And we're gonna do the same thing. We're gonna put down our brackets. And am I gonna put kilometers squared in the bottom or in the top? Bottom, good. And then miles squared in the top. And remember that these are just the units, right? Like with miles squared and kilometers squared, I'm not squaring anything. I'm not gonna square these numbers when I do this. Those are just the units. Okay, so then we said that there were 2.54 kilometers squared in 1 mile squared. So good, kilometers squareds cancel. And we end up with 14.27 divided by 2.54. So we get 5.6 miles squared. All right, last thing here, I think. Well, yeah, is temperature. Okay, so we got a couple more questions, but we were talking about this before, right? So if you see like on the TV that it's like 90 degrees out today, what unit of measurement is that? Probably
Fahrenheit.
yeah, it's probably in degrees Fahrenheit, right? 90 degrees Celsius would be like, you know, killing you. That would be way too hot. Yeah, you would. You'd be on Venus or something. Okay, so both SI and Imperial units are commonly used. So it could be degrees Celsius. It could be degrees Fahrenheit. It's a little annoying because they're both degrees, right? They say degrees Fahrenheit and they say degrees Celsius. but they're different measurements, right? So these are our two formulas. These are on your formula sheet, both of these ones. And this helps us convert from Fahrenheit into Celsius or from Celsius into Fahrenheit. We can just go back and forth. All right, so let's do that. So this question says a recipe requires an oven to be heated to 180 degrees Celsius, but the oven's temperature is given only in degrees Fahrenheit. At what temperature should the oven be set in degrees Fahrenheit? Well, let's see. So degrees Fahrenheit, I'm going to use this formula because this is the one that we want for figuring out degrees Fahrenheit, right? That front one. So I'm going to write that again. We're going to say F is equal to C times 9 over 5 plus 32. I'm going to write it one more time because it might be written a little different. It might be written like this. F is equal to 9 over 5 times C plus 32. For me, that one actually seemed like I like the look of that one a bit better. It's like the way we're going to do it. But anyway, what we do here is we're just going to input whatever the degree Celsius was into the equation. So I'm going to put 180 in for C, right? That's my input, and I want to get an output. So anyone that's into coding, this is called a function, right? This is what we'd be doing, right? So the input, so we're going to say Fahrenheit is equal to 9 over 5 times, and then we're going to put in 180. And then the way I recommend putting in 180, this is the way I always do it, is put it in brackets, right? So just put brackets there and then 180. So the reason why I do that is pretty much anything that I have like sitting there with brackets, that's what I put into it. It's like anything in the middle there, that was substituted in. And then plus 32. So now, that part was easy. I just want to make sure that you guys can punch this into your calculator properly to get the number out. So can you guys do that now? Can you try punching that in? All right. So let's make sure we get the same answers here. So I'm going to do the first part, like that one first, 9 over 5. So let's go 9 divided by 5. And on your calculator, you can push equals. So that's 1.8. And the good thing about your calculator is that it's storing that number right now. So that number is in your calculator, like ready to be used for the next part of this. So now what I'm going to do, since I know that's 1.8, is I'm not going to push like, the C button to clear it or anything like that. I'm just going to press times, because what that did is that took 1.8 and now it's going to go times whatever I want to do. So I'm going to 1.8 times 180. So just, it's already going times, and then I'm going to type in 180. And I can push equals at this point. So 324. So what that means, like where we're at, all of this to this point was 324. So what's the last thing we got to do?
Plus by 32.
Yeah, we got to add 32. So we're going to go plus, and it's already stored in there, right? It's ready for me to use that 324. So I'm just going to go plus 32 equals. So 356. Okay, so all of that, kind of ran out of the room here, but in Fahrenheit, it should have been set to 356 degrees Fahrenheit. Yep. All right.
450.
Or 450, yeah. Yeah, that's right. Okay, so now, we got like a weird, that should have been like degrees Fahrenheit, I think. A weird little thing there, degrees Fahrenheit, so that should have been. So in North America, the highest recorded temperature was of 134 degrees Fahrenheit, was recorded in Death Valley, California in 1913. What is the highest recorded temperature in degrees Celsius? So this just requires we use the other equation now, right? So we'll use this guy. Okay, so Celsius is equal to 5 over 9. Oop, 5 over 9. Bracket. Let me make sure I get this right. And then Fahrenheit minus 32. So same thing, we're just going to put it in, right? We're going to put this number, this 134, into our F value. and see what we get out for C. So we'll go C is equal to 5 over 9 times 134. And I'm going to put that in brackets too, just to remind myself. That's what I like put into the function there. Minus 32. And that's kind of it. So one thing to watch on this one, though. Do you guys remember bed mass? Do you guys remember your order of operations that we've like talked about before? Okay, so all that, like when we have like bed mass, it's like brackets, exponents, division, multiplication, addition, subtraction. All that really matters with that bed mass thing, I actually don't even like it at all, is that you just do inside brackets first. So it just requires that we do this part first. We got to go 134 minus 32, right? Just inside those. So what is 134 minus 32?
102.
Yeah, 102, good. So I'm going to keep this as 5 over 9 times 102. And then we're pretty close. So let's do it the same as last time. So I am going to clear my calculator now because I've got numbers in there from before. So push the C button. And then it's going to be 5 divided by 9 equals. So it gives me all those numbers. And this is why it helps to keep it in the calculator, because I don't want to write out 0.555555555, right? It's already stored in there. It's good for me to use for the next one. So now I'm just going to go, okay, that number times 102 equals. So 56 point, and I'll round that up to 7. So C is equal to 56.7 degrees Celsius. That's hot.